In this last section, we're going to talk about titration. So acids neutralize bases, like we learned in the last video, but only in the right proportions. You just can't add any random amount of base to an acid or any amount of acid to a base and get a perfect neutralization. It needs to be the exact right proportions in order for neutralization to take place. So titration is a process of adding a known amount of solution of known concentration to determine the concentration of another solution. We do this by achieving neutralization in the lab. So these are the steps that we follow, and you're going to do this in lab. You're going to actually titrate acids and bases together, and this is how we're going to do it. So a measured volume of acid of unknown concentration is added to a flask. Then several drops of an indicator are added that will change color when neutralization is achieved. A base of known concentration is slowly added until the indicator changes color and we measure the volume. You can then solve for the unknown using the titration formula. So here's the titration formula. So this is on your reference table, and this is a common question on the New York State Regents. So you don't need to memorize this formula, you just need to know how to use it and set it up and recognize when to use it. So the formula is really quite simple. The MA stands for the molarity of the acid. That's either going to be known or what you're solving for. The volume of the acid is what VA stands for. Again, they're going to either give that to you in the problem, you'll read that off of your titration apparatus, or it's something you'll solve for. MB is the molarity of our base, and VB is the volume of the base. So here's an example practice problem. A student completes a titration of adding 12 milliliters of NaOH of unknown concentration to 16 milliliters of 0.15 molar HCl. What is the molar concentration of the NaOH? So if this was on a Regents, bell should be ringing that it's time to do the titration formula. Right off the bat, they use the word titration. If they maybe change the word to neutralization, it might be a little harder to recognize it. But the fact that they're giving you milliliters, volumes of NaOH, you should recognize that as a base. And volumes of HCl, you should recognize that as an acid. And they're talking about molarity here. You should know to use the titration formula here. So let's rewrite the formula. MA times VA equals MB times VB. And let's plug in some of the values that they've given us here. So they told us in the problem that we're adding 12 milliliters of NaOH. So NaOH is a base. It's a metal in a hydroxide, a metallic hydroxide. So that's our base. They also tell us that we have 16 milliliters of 0.15 molar acid. So the HCl is our acid, so 16 milliliters is our VA. And they told us the concentration was 0.15. That is our MA, the molarity of our acid. And they want to know, they want us to solve for the molar concentration of the NaOH. So that's the base. So we're solving for MB here. Okay, so all we need to do is isolate the variable by dividing both sides by 12 milliliters. On the right-hand side, it will cancel off. I like to put brackets around these numbers, so when I punch this in my calculator, I can do this all at once. 0.1 or open bracket, 0.15 times 16.0 close bracket divided by 12, enter, and you'll notice milliliters and milliliters cancel. I'm left with molarity, which is a unit of concentration, which is what I'm solving for, so I know this is set up right. So if you punch this in the calculator correctly, you will get 0.2 molar solution. All right, let me show you one more problem. A student completes a titration by adding 36 milliliters of 0.16 molar KOH to 12 milliliters of H2SO4. What is the molar concentration of the H2SO4? Okay, so we'll start with our titration formula and plug in some of our knowns. We have 36 milliliters of KOH, so that's our base. It's a metallic hydroxide. We have a concentration of the base is given to us as 0.16 molar KOH. and the volume of the acid is given to us. We have 12 milliliters of H2SO4, which is sulfuric acid. Okay, and they want us to solve for the volume of the acid. I'm sorry, they want us to solve for the molarity of the acid. They gave us the volume of the acid. They want us to solve for the molar concentration of the acid. So again, we're going to isolate the variable by dividing both sides by 12. And that will cancel. Milliliters will cancel on the right-hand side. And if you do this math, you'll get 0.48 molar. And that will be wrong. And you might be asking yourself, well, I plugged all the values in that you told me, and I punched in my calculator correctly. And the reason it's wrong is due to a bit of a trick here. So if you look at the acids and bases that are used, we have a metallic hydroxide, so I have one OH ion, but in my acid here, I have 2 hydrogen ions. So remember, in order for neutralization reactions to happen, the concentration of hydrogen ions needs to equal the concentration of hydroxide ions. And in this case, when they are not equal, your answer might change. Now, this is very rare on the New York State Regents, but I have seen it. So you really have to be careful of your molar values here. So if I have H2SO4, I have 2 hydrogen ions for every hydroxide ion. So I'm not going to need a strength of concentration of 0.48. I actually only need half of that because I'm going to, I'm going to need technically more hydroxide ions to balance out 0.48 molar sulfuric acid. And they're saying that this titration happened with 36 milliliters of this and 12 milliliters of that. So that means the acid that we were using has to only be half of this strength. So instead of 0.48, it will be 0.24 molar. Okay, so use the titration formula for any question about an acid-base neutralization problem, or if they use the word titration, you know that it's time to go to table T and look up your titration formula. The question will always give you specific acids and bases and specific volumes and molarities. They will usually give you 3 out of the 4, and you just need to solve for the unknown. I've seen some harder problems that we'll practice in class that give you charts and tables that you need to find these values off of. And remember, in order to use the formula MAVA equals MBVB as is, the molar ratio of hydrogen ions and hydroxide ions needs to be equal. And it usually will be, but if it's not, you need to ask yourself, is the acid in a way twice as strong because it has more hydrogen ions? Or is the base twice as strong because it has more hydroxide ions? If so, then you're going to have to alter your answer accordingly. And we'll practice more of these more difficult questions in class, but the basics of titrations should be pretty easy for you, and I don't think you'll have any trouble plugging this formula in and solving for any of these unknowns.